I purchased an electric tapping arm to help out with some projects I'm working on that require a lot of tapped holes, and my shop space is limited and mounting the unit on my work surface just takes up too much real estate. I do have a pedestal in the center of my garage that was originally designed for my JD² Model 32 tube bender, which I'm currently not using. Maybe I can rig something up to repurpose that untapped asset? Let's give it a try. To make the base plate for the mount, I had some 3/8" steel plate offcuts from another project that came in handy. I'm not terribly concerned with precision accuracy here, but I did manage to throw down some blue Dykem and scribe a relatively parallel line to locate the lower mounting holes. I used a 13/32 transfer punch to mark the holes. Because I wanted to use the tapping machine on this project, I temporarily clamped the mount to my welding table and mounted the machine. Next, it was over to the drill press to make 4 9mm holes. I then used the new tapping machine to tap 4 holes for M10 bolts. Why M10? Because that's what was included with the machine. I took some basic measurements from the top plate of the mounting pedestal in order to make a mock-up in Fusion. The 2 mounting holes accept 3/4" bolts, and I used that in my calculation to locate the hole centers as well as their relationship to each other. By measuring the bolt head diameter, I can make a measurement from the outside of each mounted bolt head, then subtract 1 bolt head diameter from the result in order to get the distance from center to center. Using that same logic, I was able to calculate, or more accurately, let Fusion calculate, the hole locations on the plate by first measuring the width of a machinist's square blade, then using that in conjunction with the bolt head diameters. I used the parameters feature in Fusion to enter the plate width and length, along with the bolt head diameter and machinist square blade width that I mentioned before. I then made a basic model of the pedestal plate just for the dimensions. Then I created a new component which will be the tapping arm base plate. Once the design was completed, I sent it to the 3D printer. With the print completed, I used the go, no-go gauge to verify my measurements, and it all looked good. The next problem I needed to solve was, how am I going to drill 2 3/4" holes in 3/8" plate? I don't have a bit that large, and even if I did, I'm quite certain my old Craftsman 150 drill press would be hard-pressed to get that job done. I considered using a plasma cutter, but again, that thickness with the small plasma cutter I have would yield less than desirable results. It occurred to me that although I can't drill a 19mm hole with my current tools, I can drill one at 9mm. Once again, the old Southbend Lathe comes to my rescue. I turned some aluminum bushings with an 18mm diameter, a thickness of about 12.5mm, and center drilled a hole of 9mm. The bushings are a loose fit inside the mounting holes to make up for any drill press inaccuracy. I then used my new tapping machine to cut the 10mm threads in each bushing. The machine supplies a lot of torque, so make sure the parts are clamped securely. From Fusion, I printed out a template to mark the hole centers on the plate and drilled two 11mm clearance holes. I then inserted M10 bolts and snugged up the bushings on the bottom side. The assembly is then fitted into place on the pedestal and secured with some washers and locking nuts. It's also worth noting that I managed to mix up my drill markings, so I got some extra practice with the tapping machine. The last issue I had was that the screws I had on hand to attach the mount to the base plate were a bit too long. Buying different screws would take time. I could cut down the length of the current screws, but that's messy and then I'd have to clean up the threads. So what to do? Back into Fusion to design some countersunk washers that would fit the current screws I have, raising them just enough to be able to fully tighten without revealing past the bottom of the plate. I started by making a quick model of the tapping arm mounting base. The screws I happened to have on hand were originally purchased on McMaster Car, so I used the built-in functionality of Fusion to insert models from McMaster. Such a great accessory. I then modeled up a quick base plate and used the model of the screw to give me the final height for the washer part. I know these Fusion sections go by pretty quick. It's all to keep the video at a reasonable length. If any of you have interest in more in-depth Fusion sections, let me know in the comments. With my part sheet done, it's back to the lathe to make the 4 washers. I trued up the end and brought the piece to diameter. I then drilled the 11mm clearance hole. I wanted the washers to self-center, so I used a countersink bit and went deep enough to match the screw head. I broke the sharp edge and added some Daikin blue. I used a small heat torch to speed up the flash off. I marked the cut and parted off, which works so much better on this lathe ever since I did the V-belt pulley conversion in the video linked here. I had enough stock left to cut the second washer, then I needed to re-chuck, which required dialing it in. I lost a little concentricity, but these are not critical parts. With the 4 washers in hand, I installed the mount to the base plate, all while experimenting with some artsy out-of-focus shots. The arm has a collar that can be used to set the height of the tapping machine. The lowest position was suitable for my purposes. Finally, the machine is installed on the mount. The cap is screwed on, the power is applied, and my new tapping machine is ready to take on my next project. Well, function over form on this one. It's not necessarily pretty, but it gets the job done and allows me to move on to some more interesting projects. Stay tuned for those. In the meantime, if you have any comments or questions, you know what to do. I always love hearing from you. If you enjoyed the video, please strike a like and consider subscribing. Every interaction is so helpful and appreciated. Until next time, I'm mainejason. Get out there and give it a try.